Okay, so hopefully you have watched some stuff on the notes on the Circle Notebook, either mine or Mr. McGregor's or someone else's. Um, but I am going to go over now a couple of examples of in your packets that I'm going to give you so that you feel more comfortable on how to use them. Um, Remember also that I am posting all the answer keys up there, but I want you to be prepared for the first homework quiz that you're going to have, so please try all of these. Okay, so number one says, name 3 chords. So we're looking at this circle right here about chords. And if you remember, and I will show again, on your first page of your circle book, we've got a chord right here. And a chord is a segment that connects 2 points on a circle. So we're looking for chords. So a lot of people see these right away. We've got A to F. And remember, when we're doing anything, we want to put the line on top because we're talking about a segment. We're looking at chord F to E as well. Anybody can think of what the third chord would be. It's the one that's most forgotten. It's a special chord. It is the diameter, A to D, going right through there. Now remember, none of these are the radii for chords. A lot of people want to say like F to G. There should be no G included in any of these when we're talking about them. Okay, diameter we've already talked about. That's A to D. It's that chord right there. Okay, if A to D is 12. Now each of these are a what if question. None of these are given a length. This is if it was this, what would the next one be? So I get some students that are a little bit mixed up on that. But we're looking from A to D is 12. Now 12 would then be the diameter. So I like to make myself a little note of that. And then what is the length of G to C? Now if I look to G to C is a radius. So I might make my note a little bit of that. And if you guys remember from your notes over here, a radius is a segment that connects the circle to other lines, but also, and you can write this in here too, the radius is half the diameter. Radius is half the diameter. So G to C is a radius. No, it's not a radius attached to this particular diameter, but they all have to be the same length. So G to C would have to be 6. Now we're going to skip over 5 because it's one similar, so it'd be a great one for you guys to try. And we're going to look at number 6. G to E is 9. What would A to G be? So we've got G to E right here. That's 9. What would A to G be? Now we're ignoring all the other stuff up here. Nothing has been given to us. This is brand new information. So G to E is a radius. If it's 9, A to G also has to be 9 because it is a radius. Okay? We've got number 7. Now we're forgetting all that other information. All we know is what's radii are and what the diameter is. If we're given that A to G is 108, and that's a radius, what is A, G to D? That's also a radius, also 108. So pretty straightforward. Okay, we're going to move down to the second one, which is very similar to the first. We're going to talk a little bit about radii. Radii are multiple radiuses. Okay, it says B to H is 1, but you could also say H to B. Okay, but that just counts as 1, either direction. But remember, all of my radii should involve H. So that's just my little hint for that. But it doesn't matter in which order you write the letters. We're going to look at number 5. If F to H is 25, what is C to G? Now, if we look right here, F to H is for sure a radius. It goes from the outside of the circle to the middle. Okay? If that's 25, what is C to G? Now, C to G, as you can see, goes through the middle, end points at each side, so that makes it a diameter. So if half of it is 25, the whole thing would be 50. Okay, so the front is basically just looking at those vocabulary, and we're going to go to the next page and look at some of these. Okay, the first one here that we're going to look at is number 1. And this involves a little bit more that we've done on that first page, all about chords for this. In a circle with a radius of 7 centimeters, so that's the radius, and a chord of 4 centimeters is drawn. What is the distance from the chord to the center of the circle? So let's draw that picture now. We've got a chord, okay, and that is 7 centimeters long. We've got the center of the circle. We know that it has a radius of 7 centimeters, so I can put the radius right there. And I want to know this length right here, x. Now, I didn't write in the chord is 4 centimeters long, because I want you to remember that when I do this, I'm going to make this at 90 degrees, and so this splits in half. So each of these halves are 4 centimeters. And I know that from right here. If the radius meets a chord at 90 degrees, then the chord is split in half at that point. Okay, we know that from right there on our paper. Okay, so that's, if that no longer 4 centimeters, it's 2. 2 centimeters on each side. Okay, do you guys see this triangle right here in the middle that is drawn now? That is a right triangle, so I'm going to just draw that triangle bigger. I know this side is 2 centimeters. It's half of my chord, which was 4. I know my radius is 7 centimeters. I can draw that radius anywhere that I want as long as it goes from the middle to the outside. Okay? And then I want to know the distance to the center, x, of my right triangle. So now I'm going to use the Pythagorean theorem to do this. I'm going to say 2 squared plus x squared equals 7 squared. I'm going to get 2 times 2 is 4, plus x squared equals 49. I'm going to subtract 4 from each side, and I'm going to get x squared equals 45, and then I'm going to take what? Last step, how do I get rid of that x squared? I'm going to take the square root of both sides. So x is approximately 6.7 centimeters. Okay, don't forget your centimeters. All right, number 2, I'm just going to set up a little bit because it's very similar. In a circle, an 8-meter chord is drawn that it is 2 meters from the center. What is the distance of the diameter? So this is an 8-meter chord. Again, I'm going to divide it in half. So each half is going to be 4. It is 2 meters from the centimeter, and I want to know what that radius is. So I'm going to set that up with Pythagorean theorem again, and then when I'm done, I've found the radius, but it asks for the diameter. So whatever the radius is, I'm going to times that by 2, and that's going to give me what my diameter is at the end. Okay, number 3 is really interesting. The given design has 4 congruent squares arranged inside a circle, with the corners of the squares touching the circle. Okay, so they're touching the circle. If the sides of each square is 4 centimeters, find the diameter. Okay, so if I know the sides of them are 4, I know this is 4 right here. I know this is 2 right here. So I can kind of see that my radius for this is going to be 6. Or this length, excuse me, is going to be 6 right here. Because I don't know the radius, because the radius would go here. Okay? So I also know that my length is going to be 2. So I end up with a nice triangle, 2, 6, and I'm finding that radius right there. Okay. We're going to do number 5 and number 7 below. So we're looking right here at number 5. Number 5, it has a diameter of 18 and a chord of 10. I want to find this length right here. Okay, if my diameter is 18, can you guys tell me right away what my radius is going to be? If you said 9 meters, you're correct. Okay, so 9 meters, we're going to go right here. That's going to be 9. This length right down here is also 9. That's going to matter later to me. Okay, I know the chord is 10, and because of that theorem that I brought up before, of this whole thing is 10, half of it is 5. So now I'm going to find not x, but y. I'm going to find that y value right there. So I'm going to kind of redraw that triangle a little bit bigger so you can see what I'm talking about. This is 5. This is 9. I'm going to find y. So again, I'm going to use Pythagorean theorem. Y squared plus 5 squared equals 9 squared. Y squared plus 25 equals 81. Now I'm going to subtract 25 from each side. And y squared is going to equal 81 minus 25 is 56. And then I'm going to square root 56, because that's how I get rid of square. So I'm going to get 7.48. I'm going to leave it at that. But that is not what x is. X means I have to add this 9, the radius, at the bottom. So I'm going to add 9 more. And I'm going to get 16.48 is my answer. Okay. Since the radius is 9, again, we did this by cutting this in half. This is 9 right here. This is y. Okay. And we go y squared plus 5 squared equals 9 squared. 25 and 81, subtract, square root, and then we add 9 to that part at the bottom. Okay, so we're going to do one more. We're going to look at number 7. Okay, the diameter for this is 30. The distance from the chord to the top is 25. So this is 25. Find the chord length. And we know that we can just go like this and put in the radius. Now, if the diameter is 30, the radius is going to be 15. So to find this information right here, in order to find this right here, we're going to go 25 minus 15 gives me 10. That means this top part here would be 15. They add together to give me 25. Okay, so now again, I have a right triangle, 15, 10, and we're going to call this x. 10 squared plus x squared equals 15 squared. 10 times 10 is 100, plus x squared equals 20. Oh, 15 times 15 is not 25, it's 255, I believe. Yep, 225. We subtract 100 from each side. And we get x squared equals 125. Then we're going to take the square root of both sides. And we get 11.18. Okay, so 11.18 is just half of this. So then we have to multiply that by 2 to get the whole length of the chord, which gives us 22.36 meters. Oop, up here for 16.48, I should have added meters as well. Okay. All right, so that is the examples I'm going to do for your first front and back page of the packet. And I'm going to post another video for the next one.